how would you describe the universe? Infinite, eternal? How about smooth versus bumpy? In other words, why isn't all of the matter in our universe clumped together in one big ball? Or conversely, why isn't it perfectly evenly distributed? The texture of our cosmos reveals clues about how the universe formed and what happened moments after the Big Bang. To understand this curious composition and how it changed over the history of the universe, it's helpful to think about the matter in the universe as a herd of animals. I'm Jared Kaplan, and this is How the Big Bang Governs the Texture of Our Universe. Picture a herd of zebras hanging out on the savannah. If you're nearby, maybe you're an elephant who's gone wandering through the herd, you can see all of the different things the individual zebras are doing. Maybe there are a few more zebras on your left than on your right. In other words, from close up, the herd of zebras looks inhomogeneous. But if you overlook the scene from a cliff far away, the zebras all look the same. In other words, the herd looks smooth or homogeneous. Why do these animals look different close up, but uniform at long distances? And what does this phenomena reveal about our universe? Let's rewind 13.8 billion years to the Big Bang. This was the earliest epoch in our universe's history that we think we understand. It was a time when the universe was undergoing a massive growth spurt, known as inflation. And we call it inflation because the universe was expanding exponentially fast, much, much faster than it's expanding today. Inflation left the universe smooth and empty due to the extremely rapid expansion. Inflation's impact on the fabric of space-time was so extreme that it led to quantum fluctuations in time. These delays and advances in time made parts of the universe a little bit denser than others. These small fluctuations led to the structures we see today. But how? Gravity acted as an amplifier for those inhomogeneities, causing them to collapse into stars, galaxies, and clusters, and leaving behind voids in between these celestial bodies. This is why on a small scale, we have pockets of matter, like a dazzle of zebras, and yes, that is what a group of zebras is called, that appear denser than others. But our universe appears homogeneous or smooth on the largest distance scales. Inflation kicked off an epoch of expansion that left our universe more than 27 billion light years across, and matter on one side of our universe hasn't had time to gravitationally attract matter on the other side of the universe. It's just like how zebras might form a dazzle. They might start out in random places alone, spread evenly across the savannah, but over time they begin to wander around, finding more and more friends, and forming larger and larger groups. Here, the friendliness of the zebras is an analog of the gravitational force, binding zebras together into many bona fide dazzles, which appears homogeneous at very large distances, but is clumpy close up. Thinking about inhomogeneity allows us to understand the structures and voids in our universe. It allows us to understand primordial inflation, as well as the amount of dark matter that was around during various eras of our universe's history, allowing us to characterize the formation of our universe.